A 3 AM latency spike on our agent code alerted and fully traced back to the root cause in 14 seconds flat. Once your agent is in production, you're basically flying blind. Something breaks at 2 AM and you won't know until a user complains. Longsmith traces show you the chain, but they don't cover latency trends, token burn rate, or anomaly alerting. Today we are wiring up a full observability stack that handles all 3 layers, and you will see exactly how they connect. Here is the stack that we're building. Langfuse sits closest to your agent. It captures every LLM call, every tool invocation, every decision branch, and structured trace. OpenTelemetry works one layer down, collecting infrastructure level metrics like request latency, token counts, and error rates. Now here's the thing, neither of those gives you a dashboard or alerts on its own. That's where Grafana comes in, pulling it all together into something you can actually monitor. Your LangGraph agent emits data through 2 parallel pipelines. The Langfuse SDK handles trace level detail, what the model saw, what it returned, how long each step took. Simultaneously, OpenTelemetry captures system-wide metrics and ships them to Grafana. This is important. Both pipelines feed one dashboard, so you get the full picture without switching tools. Enough theory, let's build it. Alright, let's get our dependencies installed. We need Langfuse for agent tracing, the OpenTelemetry SDK with its OTel exporter for infrastructure metrics, LangGraph and langchain for the agent itself, and python.m for our keys. Before we write any code, let's set up our environment variables. We need API keys for Langfuse and OpenAI, plus the Langfuse host URL. If you're running Langfuse locally through Docker, the host defaults to localhost on port 3000. For the cloud version, point it to cloud.langfuse.com. We also set the OTLP endpoint, and that's where the OpenTelemetry sends metrics to our collector, which we will spin up later. Now we set up both observability layers in a single observability.py file. We call getClient from Langfuse, which picks up the keys from our environment and returns a singleton client. Then we configure OpenTelemetry with a meter for custom metrics. Notice we're naming our service LangGraph agent. This is important. That name shows up in Grafana as the service label, so make it descriptive. The OTLP exporter pushes metrics to our collector every 5 seconds through the periodic exporting metric reader. Here's the core of the whole setup, a custom decorator that instruments both layers at once. We create 3 OTel metrics up front, a counter for invocations, a histogram for latency, and a counter for errors. Inside the decorator, we wrap the function with Langfuse observe decorator that automatically creates a span in the trace hierarchy, and no manual trace calls are needed. Then we record the same duration to OpenTelemetry. So one decorator gives you agent level traces in Langfuse and infrastructure metrics in Grafana simultaneously. Now we move to agent.py. Here we built a simple 2-node agent to see this in action. We've got a research node that calls the LLM and a summarize node that condenses the output. Each node is wrapped with our observe node decorator, and that's all it takes to get full tracing and metrics. The important thing to notice here is the callback handler from Langfuse langchain. We pass it into every invoke call, and it automatically captures the exact prompt, response, token count, and model info, and no manual generation spans are needed. The summarize node follows the same pattern. Decorator on top, callback handler inside. Then we assemble the graph. We wire research into summarize with a straight edge and compile it. From here, you can add branching, tool calls, or conditional edges, and every decorated node gets traced and metered automatically. We need 3 config files to complete the pipeline. First is the OTel collector config. It receives metrics on port 4317 via gRPC and exposes them in Prometheus format on port 8889. Now here's the thing, Grafana can't scrape that endpoint directly. It needs a real Prometheus server with a query API. So we add a Prometheus config that scrapes the collector every 5 seconds. It needs a real Prometheus server with a query API, so we add the Prometheus config that scrapes the collector every 5 seconds. Then the Docker compose ties it all together, the collector, Prometheus, and Grafana. Now let's create one test script. We wrap the invocation in an observe function. This creates the top level of trace in Langfuse. The flush call at the end is important for short-lived scripts, so events get sent before the process exits. You need to run it around 3 or 4 times to give Prometheus enough data points. After that we can open Langfuse and Grafana and explore what we have there. But before we do any testing, we need to run our Docker compose file. The next step is to run our test agent py file a few times. I'll come back in a bit when I run it 2 or 3 times. Alright, I have run the script a few times. Now it's time to set up our Grafana dashboard. First we need to go to data sources and add a new data source. We'll choose Prometheus. Here in the connection, you should choose your Prometheus host on port 9090. You should scroll down and press save and test. If you see the message that it has successfully queried the Prometheus API, then everything is fine. The next step is to go to Dashboards and create a new dashboard. We'll choose the option Import Dashboard. And here we'll paste our JSON model. You can find this exact JSON model in the repository. The link is down in the description. Let's load it. Here you should leave everything as it is and just press import. And great, here you can see all our data. Let's also see the last 5 minutes. We can see that the average latency for the research is 15 seconds and for the summarize it's 5 seconds. Next, let's have a look at Langfuse. Here you can see things like the total traces tracked, how much the model invocations cost, which model used how many tokens and what was the price, what is the latency, and all kinds of different model usage analysis here. Let's recap what we have built. We started with a LangGraph agent running in production as a total black box, no visibility, no alerts, no way to know when things go wrong. We wired in Langfuse to capture structured traces of every LLM call and tool invocation. Then we layered OpenTelemetry on top to collect infrastructure metrics, latency, token counts, error rates, and ship those to Grafana. Now we've got a dashboard that shows real-time trends and fires alerts the moment something drifts. This isn't just debugging, it's production-grade monitoring. Your next move: take this stack and deploy it on your own agent. Customize the Grafana panels for your specific use case. And if you want to keep building, subscribe to ByteBuilder. We've got a lot more coming.